Welcome back, students. Today we're going to be talking about writing and graphing inequalities. So first, we've got this little table to help you find the inequality symbols. The inequality symbols are what we call relational operators. Now, the same way that equals states a relationship that the left side is the same as the right side, these also are telling us the relationship between two expressions. However, in this situation, we're not talking about both sides being the same. We're identifying which side is bigger, which side is larger. So this is the less than symbol. Sometimes as we use normal language, we don't always say is less than in just our normal speak. And same thing with word problems. You're not always going to see them identify that exact same phrasing, which is why we have this reference for you to help you identify which symbol they're talking about depending on what words they use. So less than or fewer than, is greater than or is more than. This over here, the official name is less than or equal to. However, it could also be is at most, is no more than. This is greater than or equals to, but it could also be said as is at least or is no more than. So use this as you encounter different word problems in order to be able to write out those inequalities. We're going to do a quick, simple practice with identifying which of these symbols we would use. So, a number C plus 9.4 is greater than or equal to negative 6. So, C plus 9.4 greater than or equal to negative 6. 6 is greater than a number P minus 8. So we got 6, we need the greater than symbol, P minus 8. Next, 10 is no more than. So quickly check, look at your reference. What was no more than? The sum of 3 times the number y and 4. All right, so we should be using the less than or equals to symbol. 10 is no more than, meaning it's less than, 3y plus 4. 3 times the number y plus the 4. Okay, now a solution. When we were dealing with equals, the solution was where both expressions, both sides of the equation were the same. Here, we just need to make sure that, and it was always going to be the number that made it true. So it's the value of x that made both sides the same. Here, we need to find the value of x that makes one side larger than the other in the way that the relational operator identifies. Now, so a solution of an inequality is the value that's going to make the inequality true. An inequality can have infinitely many. So if x is greater than 2, well, it could be 3, it could be 4, it could be 5, it could be 6, it could be 7, it could be 8, it could be 9. There's an infinite amount of numbers that x can be and would still make that inequality of x being greater than 2 true. Now, the grouping of all the numbers, the set of all of these numbers that are solutions is what we call the solution set. What this table shows us is testing whether or not certain numbers are in the solution set. So if we have negative 6, now in order to test if negative 6 is a solution, we put it into the equation, x plus 5 is greater than or equal to negative 2. And then we have negative 1 is greater than or equal to negative 2. Now, in order to correctly identify whether or not that's a true statement, and it gets kind of tricky with those negatives, I want you to think of temperature. Which one is a warmer temperature? Which one is a colder temperature? Now, while both of these are cold, negative 1 is higher up. Okay, it's only 1 below 0. This is 2 below 0. So negative 1 would in fact be greater. This is true. So yes, it is a solution. Now here we got -2 is greater than or equal to -2. If it was not for the or equals to, that little line on the bottom, this would be false. But because that line is there, they are equal, so this is also true. All right, trying out the -8, we'd get a -3 is greater than a -2. -3 degrees would actually be colder than a -2. So this is not a true statement. This is false. -8 is not in the solution set. All right, so we're going to tell whether or not 3 is a solution to either of these. Step 1, substitute in 3. Just change the variable to 3. 3 minus 7 is -4. Now, -4 is a warmer temperature. It's higher up on the thermometer. So this is a true statement. -4 is greater than -5. So 3 is a solution of that inequality. Doing the next one, once again, we replace x with a 3. So now we've got -3 times 3 is -9. -9 less than or equal to -12.5. Well, it says that -9 should be colder, but -9 would be a higher temperature than -12.5. Therefore, this is false. 3 is not a solution to this inequality. All right, now we're going to be graphing them. So when we graph this type of inequality, it's just going to be graphed on a single number line. Now, the graph is supposed to represent all of the possible solutions. So first, we identify where's it kind of starting. So this one at 3. Now I'm going to put a circle there. Another important thing about this circle is I filled it in. It's not an empty circle. This is a filled in circle. And that's because x can equal 3. Okay, 3 is a solution, therefore we fill it in. Now, x has to be greater than 3, so I want to identify what numbers would work there. 4, 5, 6, 7. All the numbers on this side of that dot are the numbers that make x greater than 3. So I'm going to draw an arrow in that direction, indicating that all numbers starting at 3 and going this direction for all of infinity are solutions to this inequality. So this in its own way is far easier than writing out the numbers of a solution set because there's infinitely many. We could never write them all. But with a simple graph, I've indicated where all of them are. All right, so now -4 is greater than y. So we're going to start out at that -4. Notice the difference between the circles. This time I did not fill it in. This is not or equals to. -4 is not a solution. So we're going to use that empty circle. Now, y has to be less than that -4 because the -4 is greater. So I want to think of numbers that would be less than, numbers that would be colder. -10 degrees would be colder than -4 degrees. So going over in this direction is where we'd identify all of our solutions. All right, next, x is less than or equal to -2. We're going to draw the dot at -2. Think about whether or not this is supposed to be filled in or empty. Okay, so this one should be filled in. It can equal the -2. -2 is a solution. And we're going, x needs to be less than it. So the values less than -4, -6, -8, all these values are colder than -2. So we draw an arrow going off in that direction. All right, so that's how we're going to graph our inequalities on a number line. Next, we're going to write these linear inequalities starting with the graphs. Now, these graphs are going to show the age restrictions in years for 2 types of movie tickets. We're going to write the inequality that represents the age restriction of each ticket. So first, here's ticket A. I notice it's got this circle here at 12. the circle is not filled in, so it will not be or equals to. The arrow goes in the direction of lesser numbers. So 10 is less than 12. So my x should also be less than 12. Okay, so the age for ticket A has to be less than 12. So this is sounding like a kid's ticket. Ticket B, we start at 62. This one is filled in. All right, so in the former one, if a kid had just had his 12th birthday, he can no longer buy ticket A. He doesn't qualify as a kid anymore. However, in this one, the moment someone turns 62, they're going to qualify for this. 62 is a solution. It also means we're going to use the or equals to symbol. My arrow is going off in the increasing direction, 64, 65. So 64 is greater than a 62, and that's the age of ticket B as well. Ticket B needs to be greater than or equal to 62. So this could be a senior citizen's ticket. You need to be 62 or older in order to buy it. Whereas the kid's ticket, the moment you're 12, you're not a kid anymore. I hope this was helpful. Good luck with your assignment.